say all that, but.
Okay, so when you left off for lunch, we were talking about this idea that Carlos and Clarita have found we've been finding ways to represent combinations of cats and dogs that satisfy each of the individual pet sitter constraints, but they need to find combinations that satisfy all of them simultaneously. And we discussed this idea by looking over here and testing it out, right? All the inequalities must be satisfied, otherwise the combination doesn't work. 50,2 works for space, but not startup cost, so they can't have 50 cats and 2 dogs. We all comfortable with that? Okay, so at this point, I want you to take just a few minutes, maybe 2 or 3, to work with your group, your small group, to begin by listing the system of inequalities. By the way, can I erase that purple so you can see the question better? Okay. Boom. All right, so that begin by listing the system of inequalities you have written to represent the startup cost and the space pet sitter constraints. So work together to write this list for the system of inequalities. We know what we're doing for number 1? Okay, if you get done with number 1, go ahead and read number 2. And we'll get started on that one in a second, but take a couple minutes, work on number 1. Marquita? Marquita, you can jump into whichever group you would feel more comfortable talking with today, okay? All you've missed up to this point is, because we did take some notes at the beginning on the graphic organizer, but all we did is we talked through why, so it's the beginning up here, why Carlos and Clarita need to find combinations of cats and dogs that satisfy the constraint simultaneously, meaning at the same time, right? So we have the startup cost, 32x plus 80y is less than or equal to 1280. The space constraint that 6x plus 24y is less than or equal to 360, right? Because they only had $1,280. They only had 360 square feet for the cats and dogs. What your group's working on right now is number 1, listing the system of inequalities, right, that represents those constraints at the same time. Okay? So talk with each other, try to figure that out, and check with group 1 first. So what are we thinking? Well, let me ask you this. What constraints are we talking about here?
No,
Do you know what the startup cost constraint or the space constraint might be?
How could we list that?
Let's read the thing first.
That's probably a good idea.
Carlos, read.
What would the constraint look like for startup cost and space? Okay, so that's a graphical representation for the startup cost and, or well, for one, I don't know which one it is.
Alright, let's start with the constraints. What are the constraints?
One thing I will point out is there's a boundary line right here, but you have no.
Startup cost, space.
So what are those 2 constraints? Now, that's not necessarily what we're looking for, but
280 and.
how could we represent the startup cost constraint?
So how can we take those 2 constraints, which are the inequalities, and write them as a system of inequalities?
So we need one of those, but notice they're asking us to list the system.
What is the one thing we
of
talked
inequalities,
about? If you put it beside the 2 inequalities, put them together, it makes it a system.
right? We're asking you to list the system of inequalities. Is there an inequality that might
So one day we talked about,
represent the
if you have 2
startup
inequalities
cost
and put them
constraint?
together, we
What
use
would that
one
be?
thing to denote that it's a system and to put them together.
Then we do, what do you think about that idea that 32x plus 80y is less than or equal to 1280 represents the startup cost?
Solutions for systems?
Like,
How do you know?
I don't remember if it was on one of those or not.
Jaden, where'd you come up with that?
What are system of equations?
Where'd you come up with that equality?
There you go.
Constraint.
A system is a set of parts of.
So you put a bracket.
How did you come up with 32x plus 80y is less than or equal to 1280?
Around the whole thing.
Yeah, so just we're going to write the 2 inequalities first. So
1,000.
I mean, it's on the board, isn't it?
380.
But how do we know, like,
360.
let me ask you this, how much money did Carlos and Clarita have to spend?
Beside each other.
They had
Put
one
them,
on $280.
one on top
How
of
much
the
did it cost for each cat pen? $32.
So
How much
that's
did it
about
cost for each
85.
dog around? So
So dividing
32
into
times
half,
X, the number of cats,
so
plus
if you wrote
80 times Y, the
the
number of dogs.
280.
Has to be less than or equal to 1280.
Now you wanna make sure
Does
you
that
write
represent
the
the
entire
constraint
thing,
that
so
says
this,
they
this isn't
cannot spend
enough,
more
so
than
that just tells me
$480?
360 and
So there's an inequality,
1280.
right?
But you wanna write the whole inequality,
Like this.
yeah, like that.
Ah,
And, yeah, so this is right, now you technically only have to have the first one, but this is also right. Your squiggly brackets look way better than mine do.
Which one, you all talk about it, which one do you think it is?
Mine just looks like a scribble.
When did we go on the
Then you write both of them,
Do you know why?
or to defeat it,
Yeah, we're
Do
gonna
you know why?
feeding time and pampering time today.
Because you gotta find it's greater than equal.
Right, well, why is that startup? Why is that not space?
So now you
Oh,
can
it's
start
not,
thinking
it's a
about number
bracket.
2 if you
Oh,
want. Yeah, it's a squiggly bracket.
And I'll talk to Dave and make sure you understand why. So what y'all come up with? Okay. So where is that coming from? Why is that your system of inequalities?
because it represents startup cost and space.
Okay, so we have these two different inequalities, one for startup cost, one for space. But why'd you put those brackets on there?
That's what it said new on the graphic organizer.
Okay, do you know why it says that?
Because.
That's a good thing to recognize, right? Like, look at that graphic organizer, it tells us to.
Because it shows they're together.
A system works together, doesn't it?
Mm-hmm.
So when I put those curly brackets, it tells me to put them
Together.
together, okay? So go ahead and read through number 2, we'll start up in just a second.
I'm seeing curly. There ain't got no kernels. This is a bracket with a little E at the end. What's that?
Number 2. Are you there?
Yeah, trying to at least draw the combination. Did you read number 2 yet?
Yeah, but I don't want to do it.
Okay, we're gonna talk about number 2 and 3 in just a second. Let's have a whole class conversation though, about number 1 before we move forward. Okay, so, I saw group 1, Jaden and Bentley, you wrote your system of inequalities this way, okay? Deacon, I don't remember if you got it down, Marquita, but make sure you have, well, copy down one of them at least, and we'll have a discussion about it. And Mila wrote down this one, okay? So do both of these ideas contain the constraints, the inequalities that are necessary? Okay? But I will say, only one of these is a true system. Why is the one with a curly bracket a system? So remember, by definition, right, a nervous system is, for your body, right, is a connection among things that are working together, right? And so when I ask us to, list the system of inequalities, all you have to do is write the inequalities, but you do need to group them together. We good with that idea? So we do want to recognize, like, this is how we write the system. There is one thing, so this is how Mila represented it. There's one thing that I wouldn't necessarily do here. Do you know what it is? So you're just going to drop those off?
Plus the signs, wouldn't you? Because you want to keep them as expressions, right?
But do I want just expressions? I want what?
Constraint.
Constraints. So, the requirement is that all of the costs, the startup costs, have to be what?
Less than or equal to.
So do I want to drop off that 1,208? No, not necessarily.
You have to like show which inequality is which.
I would do that. Now, that's not what I was thinking here. Let me point this out. Do you still know that those two inequalities are working together? So do you need the curly bracket on the back end? No. To do a system, right, to show that they're connected, you just do the curly bracket on the front end. Okay? So if you have this here, make a note, right? We have to group together. So see next example, right? We don't want to just erase our mistakes. We want to learn from them. So see next example. And then over here, we want to note curly brackets, group the inequalities together, creating a system. Right? So make a couple of notes to yourself about that so that you have that as a reference for later, because we're working with systems from now until the end of this unit. So we want to make sure we have an understanding that, hey, those curly brackets, that's important for grouping the inequality together. Marquita, have you written that down? Now, I will say I do like what Mila noted of, hey, I would define or explain which of those inequalities represent what. What is this 32x plus 80y less than or equal to 1280 representing? So I might make a note or draw an arrow showing that or write it above there. You don't have to, but I mean, if I just had this, I would just think it's a random system, right? But there's meaning to this system, so I need to indicate its startup cost. And what is 6x plus 24y is less than or equal to 360 representing? Space. And as normal, I would also define my variables. What does x represent? Cats. Why?
Because we don't know how many numbers I lost.
Sorry, that's the wrong y. Like literally, what is the variable y representing?
Dogs.
Dogs. That's what I meant. That was my bad, Deacon. As soon as I said that, I was like, oh no, I'm going to confuse somebody. Yeah, so we don't know how many cats. That's why we're using a variable there. We don't know how many dogs, which is why we're using the variable y. I just meant, what's that variable? So don't forget, we want to define the things that we're working with. We want to make sure that we indicate what everything means. And then notice you also need to take notes about explaining why this stuff is there. So, number 2, find at least 5 combinations of cats and dogs that would satisfy both of the constraints represented by this system of inequalities. How do you know these combinations work? Let's just start there. If you finish with 2, move on to 3, and I'll try to explain it there. But what I want to point out is use your resources. You can look back at 5.2 and find lots of different combinations. And what your job is to find 5 combinations that would satisfy both of the constraints at the same time. Any questions about that? Cool. So start talking with your groups, discussing how we're going to find combinations that work with both at the same time. Really quickly, did you hear when I talked about the fact that we don't want that there? Deacon, have you gotten 5.2 out?
Yeah, that's right.
So have we started looking?
Not even related.
Why didn't you tell me you had nothing written? I could have printed stuff out for you like I printed out for Mila.
Nothing written. What do you mean?
Look at 5.2. How much do you have written on that page?
Not much.
Not much. So how much is that going to help you today?
It's fine.
You're just going to look on hers? You might need more later. Notice we need to take notes, otherwise it's going to be really hard to do all this stuff later. So what are we thinking? How can we find combinations that work for both of the inequalities?
From these points.
Okay, so we do have some points already there, right?
So how do you know?
Okay, so how are we going to use those points to make sure it works for both? Because I think this one's only startup cost.
Are we trying to find out like
Oh, these right here.
the, like how many like cats and dogs?
You want cats and dogs, right? That's what we mean by combinations of cats and dogs, right? X and Y.
To not go over the startup cost and the
So we have to be less than or equal to the startup cost, but we also need to be less than or equal to what?
360.
The space, right? Yeah, the space constraints. So how are we gonna find
I could have
combinations?
sworn we've already done this.
Yes, well, we've done them individually. Remember, that's what we talked about at the beginning. We have yet to do them together.
That was what,
That was
5.2?
5.2. That's what I was telling you earlier. We did this with 5.2.
What did we do on 5.3?
So some of them, but we need more stuff written down. We like made graphs and everything with it too. So here's the thing, Mila has some points here, but remember those points only work for one of them.
No, this is,
5.1, oh crap.
that would be,
Just right based on what?
yeah, but this says that is
What
fine
do you do on that?
for exactly.
That's the $1,280 was the startup cost. That's not the space and startup cost.
5.1. I got more stuff written on 5.1.
Okay, well, let's look right here. So I do want to point out, everyone look at the notes that I printed out from Mila. We do have sets of points here. By the way, Mila, did you look at the fact that there's a second page?
Yeah.
Okay. How do you see the combinations on the second page? So notice I didn't write out any combinations here, guys. For the second page at least. How can you see combinations of cats and dogs that work for this space constraints?
Oh, the graph thing.
What about the graph?
The points plotted on there.
X
So
represents.
do these points work for the constraints?
Oh,
So
Obviously, this is the y-axis, which is the
Mhm.
y point that have 15 dogs and 60 cats. Right? No, it's reversed, ain't it?
how many cats are right here?
Is that on 15?
It is 15, but how many cats is that? 0 cats and 15 dogs.
What's the?
Zero cats.
60.
60 cats and how many dogs? 0 dogs. We would need to be careful about that, right?
Right. But
So-
this would have been.
What is that?
That's
So why
like
do
part
we
of
have
the
the graphs now?
differentiation.
So remember, how do we indicate the points that make the inequality true? We're shading them, right? So could you use that information to help you find some combinations that work for both? Because
So
notice
we
they're
know
not all
these
the,
are true.
so yeah, notice we don't have all the same points over here, but this point right here, 10 comma 10. Does that work over here? 10 comma 10. Okay, so there's a combination of cats and dogs. Use that information. Also, guys, if you are missing these resources, go on to Schoology. I've made those solutions up available so you can print them out. So you can have,
Since you just
this stuff
typed
written
it.
out. But there should be a graph with this that would be helpful.
5, comma 9.
I need you writing this stuff down, otherwise it's hard to use and learn from.
Please excuse this interruption. We need Marquita Adkins for checkout.
She's on her way. All right, let's have a quick conversation. I know there wasn't many, but
Comma 3.
Mylan Deacon, can you tell us a couple of combinations of cats and dogs that you found would satisfy both of the constraints?
10 comma 10.
Okay?
5, comma 9.
Any more, or is that where you got to?
30 comma 3.
Okay.
40, comma 7.
Man, I was blowing through this.
And 40, comma 5.
Was it 20 comma 7?
Yeah. And 40, comma 5.
Okay. So, Jaden and Bentley, did y'all find any combinations? What'd you find? 14 comma 10? Anything else? 15 comma 10. Okay. So that's all you got so far? So let me ask you, so notice we have our two groups here, but Jaden, how did you find these points, these combinations that would work for both?
So we made graphs the last time,
Yeah.
and they put them the same way, like kind of like 10, and then the 5's on the x-axis,
Mm-hmm.
the y up to 20,
Mm-hmm.
and the second side. Felt pretty confident. All I had to do was pick points that were under both of the boundary lines on both graphs.
Okay,
I was okay with them the way, because, we were trying to figure out the graphs, I also wrote some combinations.
okay. So you found points under both boundary lines?
Yes.
Okay. Why did you know it had to be under both of the boundary lines?
Because in both inequalities, they both say less than equal to.
Okay. And now I will point out, don't forget, sometimes that can reverse direction when it comes to, when we have negatives, multiplying and dividing. So we want to be careful. We want to remember we're going to shade the things that make the inequality true, right? So that we found out that those were the points underneath. Mila and Deacon, can y'all explain how you found these points? I think it was pretty similar.
On the second page of 5.2,
Mm-hmm.
it's a graph and it shows, like the shaded part. We got points on the shaded part that made it both of them true.
Okay, so, and this is the one thing I do want to point out. So Jaden, your idea of like points under both boundary lines works in this one specific situation. But I really like what Mila's saying there where she says, hey, I just looked at the shaded region. If it was a point within both shaded regions, it worked. And that's what your idea was, but that language is something we want to emphasize. Right, so these are points within both shaded regions on graphs, right? So make sure you have that note to yourself. We're not going to write it down right now, but I will remind you that means that those points do what to both inequalities? Make them true, right? It's not just going to make one inequality true, it's going to make both of them true because it's within the shaded region of both. And why do we shade either above or below that boundary line?
To show the solution.
To show the solutions, right? We shade to show those solutions. All right, I'm going to leave that there, but I'm going to quickly go to the homework. Just erasing this. Make sure you have that blue stuff down. So 5.5, ready, numbers 1 and 2, go set number 5, go number 11. Again, is this less homework than normal?
Yes.
So that you can use what two resources online? Desmos and Simbo Lab and Khan Academy if you need it. And what's going to be your job with this homework?
To do it and justify.
To justify it, right? Justify your boundary line, justify your slope, justify your y-intercept. So keep those things in mind. Alright, so 5.5, ready, numbers 1 and 2, set number 5, go number 11. It was great learning with y'all today.